Today I'm going to solve LeetCode problem number 875, Koko eating bananas. In this problem, we are given an array of piles where the value at ith index represents the number of piles, number of bananas in that pile, and we are also given an integer h where h represents the number of hours that's available for Koko to eat all the bananas in all of the piles. And what we are given is that if a pile has k number of bananas and if the speed of Koko is k, then Koko can only eat all of them and will not eat more bananas during that hour. That is, Koko will not eat any more bananas from other piles if a pile has less than k bananas. So let's just see how we could solve this problem and the problem statement here in more in this example. So we are given this pile, right? So Koko is given 8 hours, so we are given a total of 8 hours. Within these 8 hours, the Koko has to consume all of these bananas. So she could eat with the speed of 11, right? She could eat in the speed of 11. So if she eats in a speed of 11, she can consume all of these bananas in 1 hour. All of these bananas in 1 hour. She cannot consume 7 plus 3 in 1 hour because she can only consume one pile in 1 hour, maximum of one pile. So she consumes this in 1 hour and then she consumes this in 1 more hour and this in 4 hours. Well, basically she could consume it in 4 hours, but she still has 4 hours left, right? And this is the speed. So basically if we reduce the speed, let's suppose if the speed is 10, then she could eat 3 bananas in 1 hour, 6 in 1, 7 in 1, and 11 in 2 hours, right? Because she has to eat 10 bananas in 1 hour and then she will take 1 more hour to eat one banana. So that would be 2. So basically the number of hours required is equals to 5 now, but she could still go slower, right? She could use all of these 8 hours to consume the bananas. So what would be the actual value, the slowest that she could go so that she finishes eating all of the bananas in 8 hours? So we are going to use, to solve that, we are actually going to use binary search. But before that, let's see. We saw, right, Koko can eat maximum of 11 bananas. So this is the maximum speed she could reach. And what would be the minimum speed? Well, she could start from eating 1 bananas, right? But 1 could be too slow and 11 could be too high, right? So what we do is we take a value between these two values. So we take a value between these two values, so that would be an average of these two values, which would be equals to 6. So we assume that 6 is the speed, so we take 6 as the speed of Koko, and then we calculate if Koko can eat all of these bananas with the speed of 6. So with the speed of 6, which means that in 1 hour she could eat 6 bananas. So to eat 3 bananas she requires 1 hour. To eat 6 bananas she requires 1 hour. To eat 7 bananas, how much hours would she require? Well, for that we divide it by 6. That would be 1 point some value, some decimal places. So we are actually going to take the ceiling value. It would be 2 hours. You could just simply look at this calculation in this way. So to eat 6 bananas she requires 1 hour, and to eat 1 more extra banana she is going to take the 1 whole hour, because she cannot eat from another pile in that same hour. So for this she requires 2 hours. For this again 11, right, which would be 6 plus 5. So she eats 6 bananas in 1 hour and then remaining 5 in the next hour, so that would be 2 again. So how many hours is it taking? 1 2 3 4 5 and 6. So she's only taking 6 hours, right? And 6 is still less than 8. So what do we do? Should we increase the speed or should we decrease the speed? Well, basically we need to decrease the speed, right? Because decreasing speed means taking more hours to do the same thing, right? So we are going to decrease the speed. So whenever it's decreasing speed, let's just write it down. So decrease speed only when the hours that we calculate is less than the given hour, the value of h. So since 6 was less than 8, we decrease the speed, right? So in order to decrease, now this becomes our left bound and this becomes our right bound, and now we take a middle value between these two, right? So the middle value would be the average of these two, which would be a value 4, since we are taking, okay, let's take the floor value. So that would be equals to 3. 6 plus 1 is 7. 7 divided by 2 is equals to 3.5, and we are taking the floor value, so that would be equals to 3. So now when Koko consumes with a speed of 3, so how many hours does he take? So let's calculate that. So that would be 1 hour for 3 bananas and 2 hours for 6 bananas. And to eat 7 bananas he would require 3 hours, and to eat 11 bananas he would require 11 divided by 3 would be equals to 3. If we take the ceiling value, that would be equals to 4, right? So that would be equals to 4. So the total number of hours is 4 plus 3, which is equals to 7, plus 2 9, plus 1 equals to 10. So that's 10, which is greater than this value, right? So now what we do is we take this, we actually need to increase the speed now. So to increase the speed means we are going to take a value. Koko has to eat more bananas, so we are going to take a value between 3 and 6. All right, so between 3 and 6 would be a value of 4. We are just taking an average. 6 7 8 9. 9 by 2 is equals to 4.5, and the ceiling floor value is equals to 4. So that's what we take, and then using this speed value, now we calculate the number of hours. So to eat 3 bananas it takes 1 hour. To eat 6 bananas it would take 2 hours. To eat 7 bananas it would again take 2 hours. To eat 11 bananas it would take 3 hours. So how many hours is he consuming? 3 4 5 6 7 plus 1 8. So that's equals to 8 hours, right? Since we found the value 8, now we are going to return the speed. So this 4 becomes the result that we are looking for. So that is how we are going to solve this problem. So we take 1 as the minimum speed and 11, which was the maximum of all of the values in this pile, as the maximum speed, and we then take the middle values every single time, and we decrease the speed when the number of hours is greater, and then we increase the speed when the number of hours is less. Yeah, so we decrease the speed when the number of hours that we found for this given speed is less than the given hour, and we increase the speed when the number of hours C requires to consume in this given speed is greater than the given speed to us. So that is when we increase the speed, because we need to decrease the hours, right? So this is actually a binary search solution, and the binary search can be solved in log of n time complexity. So now we know the process. Let's solve our problem. So for binary search, what are we going to need is a function, binary function, and for that we also need the maximum value in these piles, right? So let's define a max pile variable and set it a value 0, and then for each of the pile in the piles array, we are going to calculate the max pile. So now once we have our max pile, we are going to use a function, a binary function. So we are going to create a binary function, binary search function. And let's also create a function where we would identify the hours taken for the given speed. So hours equals to function for the given speed. So if that's the given speed, then let hour is equals to 0, and for each of the pile, to each of the pile, so we add to our total, to our hour, the number of hours that's taken to eat all of these, the bananas in the given pile. So we are going to take the ceiling value from the pile, divide it by speed, and then finally return hour. So now that we have our hours, we will perform our binary search. For that we need the left and the right value. That is, the left value will always be 1, and the right value will be the maximum value in the pile. So we could just write it. So we could instead write it 1, but let it be that. So now we are going to use a while loop, and while left is less than right, what are we going to do is we are going to find our average speed. So for that, let average speed be equals to math.floor value of left plus right divide by 2, right? So we divide this by 2, so that's our average. So why am I getting an error here? Okay, so now we have our average speed here. Okay, let me just write it like average. Okay, so now this average speed we are going to use to find the number of hours it takes for Koko to eat at this given speed. So let hours is equals to okay, let me redefine this function. Calculate hours, so that would be total hours, and then this returns the total hours. So all right, so we passed our average speed. All right, so now we check if the average is the hours that we received is less than or equals to the value h, the hour that we are given. If that is the case, so what do we have to do? Since C is taking less hour, which means that she has a very high speed right now, so we need to lower her speed. So that is what we do is we we go towards the left, that is we shift our right to our mid value, and our mid value is this average speed. So now our right becomes the average speed. Else what we do is we shift towards the left, towards the right, so that is when we do average speed plus 1. And then finally we are going to return our left value, which would be the average speed. Now let's try to, okay, before that let's call our BFS binary search function with a value of 1 and max pile value, and return the value received from this, and try to run our code. Okay, so something is wrong here. Let's look at this solution and what went wrong. Okay, so that is pile of piles. Great, let's submit it. Awesome. So let's look at the time complexity of this solution. So the time complexity, since we are taking a for loop, that would be O of n, and the binary search is O of log n. So the time complexity for this solution is basically O of n. We also have a for loop here, so that would also be O of n. So O of n plus O of n, and this is O of log n. So since we are calling this function from here, so that would be O of n log n. So that's our time complexity, and our space complexity is constant here.